So let's find this limit. Now, if you plug in 0, you're going to actually get indeterminate 0 over 0. So you know there's some algebra involved here. So the algebra that's involved here is to multiply everything out and then factor, and what will happen is an h, when you factor an h out, you'll be able to cancel it. This is actually the definition of derivative, as you're going to learn soon. So it looks kind of weird. You're like, what is this stuff coming from? What this basically is, this is the limit as h goes to 0 of f of x plus h minus f of x all over h, which is the definition of limit, just so you know. So when you see something like this, you should think to yourself, oh, this is just the derivative. You'll understand that as you get more into calculus. It's like one of the building blocks of calculus. Okay, so, but algebraically we can do this. We just have to kind of do it. So it's x squared plus 2xh plus h squared. You get what I did there? I just did that. I just foiled this out, but I can do that in my head, and hopefully you can too.
Yeah.
And then distribute this 2 in, and what do I get? 2x plus 2h minus 3 minus, and then I'll just leave that thing there. Okay? So now this, see how this negative right here is really going to distribute in as negative, 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 positive. And sure enough, that's going to cancel with that.
Wait, what cancels with what?
The x squared is going to cancel with the negative x squared because you distributed it in. This 2x is going to cancel with the negative 2x. And the negative 3 is going to cancel with the positive 3. That's kind of why this thing works.
Yeah.
And so what am I left with? I'm left only with the h terms. And of course, what can I do? Factor out an h. You got what I'm saying?
Yeah.
So I'm factoring out an h now, and I get 2x plus h plus 2 all over h. And that's the limit as h goes to 0.
Okay. And then you just
now that I've isolated that, I can cancel an h out. And then I can plug in that, and I'll get what? 2x plus 2. That's the limit of that function as h goes to 0. It's an actual function, which, by the way, is the derivative of your original function, and your original function was x squared plus 2x minus 3. That was your original function. And this is the derivative of that function, and you'll learn the shortcut way to find that. And I'll spoil your teacher's joy right now. The way to do that is to take this exponent, bring it down, multiply it in front. Same with that exponent, bring it down, multiply it in front, and reduce the exponent by 1.
Yeah. I did this.
So that's 2x plus 2.
You showed me really poorly today, and I didn't understand.